a half-life is, well, it's what I'm going to describe. So it has to do with radioactive materials and how long it takes them to decompose. So a half-life is how long it takes the original amount to decompose to half of the amount. So let's say you have some radioactive material and you have 100 grams of it, and the half-life is 12 minutes. Okay, so 12 minutes go by, and now you have 50 grams. And then another 12 minutes go by, making 24 minutes total. Then you'd have 25 grams. And if another 12 minutes go by, so after 36 minutes, then you'd have 12.5 grams. And it keeps working like that, okay? So that's what a half-life is. A half-life is how long it takes for the amount to decompose to half the original amount. So it follows a growth model, but it's a decay, so it's the growth and decay model. Okay, so here comes an example. The half-life of magnesium-27 is 9.45 minutes. Okay, so this is the half-life right there. How much of a 10 milligram sample will be left in 6 minutes? Okay, so first of all, I want to tell you, when it says magnesium-27, the 27 is just part of the name. It's an isotope of magnesium, so some radioactive. Magnesium I don't think is normally radioactive, but this is some isotope, some change in the element. It's a different element that's radioactive, okay? So it says the half-life of that stuff is 9.45 minutes. How much of a 10 milligram sample will be left in 6 minutes? Okay, so we don't have what K is. So let's get our growth model here. A equals A naught e to the kt. All right, so we know that we're starting with 10 milligrams, right? And E is E. K we don't know. But the time is 9.45 minutes. How much do we have after that 9.45 minutes? Well, remember, we started with 10, so then we would have half of that, which would be 5. Whoops, my screen's moving. Okay, so there's our formula. Then we can solve for K. So I'm going to divide both sides by 10. And I would probably put a decimal here, 0.5. A lot of times I use fractions, but in this case, I would probably put it as a decimal. Okay, so then I'm going to take the natural log of both sides. So this is very common when we have these growth and decay models, and you have e to some exponent. You're going to take the natural log of both sides. Sometimes my students say natural log it. So they mean take the natural log of both sides. Okay, so on the right, it's just that exponent, 9.45k. On the left, it's the natural log of 0.5 divided by, well, now we have to divide by 9.45. So what is k? K is the natural log of 0.5 divided by 9.45. Okay, now what does the question ask? How much will be left after 6 minutes? So we're going to take our K and put it into the formula. So over here, we're going to change our model to say how much stuff do we have. We started with 10 milligrams, e to the, and now we have that natural log 0.5 divided by 9.45 t. But our t is 6 minutes. So 10e, and then this is going to be natural log 0.5 divided by 9.45 times 6 minutes. Okay, so that's how we're going to figure it out. Now we'll have to put this in a calculator. So the way to put it in the calculator, 10e, And then on my calculator, it automatically gives me the exponent and a parenthesis, okay? So that's with my E button. So I hit that and that's what I get. Then I'm going to put natural log, which also puts a parenthesis, 0.5. I need to close that parenthesis off. Make sure you do that because your answer will be way different otherwise. Divided by 9.45 times 6. And then I like to close off the parenthesis so it matches up. Okay, so let's put this all in our calculator. It's hard for me to see what you're doing on your calculator, but you got to practice these. Okay, so 10, and now I'm going to hit the E button, the E to the X, and I'm going to hit the natural log. It's going to open the parenthesis, 0.5, close the parenthesis, divided by 9.45 times 6, close the parenthesis, hit the equals, and I get about 6.44 milligrams. So when 6 minutes go by, it's going to have about 6.44 milligrams. Now, is that reasonable? We didn't go a whole half-life. A half-life was 9.45 minutes. So if I only go 6 minutes, then I'm not going to get it reduced by half. So it's more than half the amount. So it seems reasonable to me. And that's the answer.